Hi guys, so today I will continue with chapter 10, which is the special probability distribution. Okay, so this is the last chapter in our syllabus in semester 2. So in this for this chapter I will separate it into four parts, which is the binomial distribution, the Poisson distribution, the normal distribution, and the distribution approximation. Okay, so let's go through with the first topic, which is the binomial distribution. So binomial distribution is used to model this situation where there are just two possible outcomes, which is success or failure. Together with this property, the following condition also need to be fulfilled. So there must be a fixed number of trials, which is n trials. The trials are independent of each other, and the probability of success must be the same of each trial. So if x is a random variable of a binomial distribution, I just write it as BD. Oops, sorry. Okay. Then the probability of x success in n trials is given by the following probability distribution function. So NCX, so P power of x, Q1 power of 1 minus x. So where n is the number of trial, x is the number of success, p is the probability of success, and q is the probability of failure. So we write is as x is as b and p. So n and p are known as the parameter of the binomial distribution. As the number of trials get larger, the calculation become tedious. Therefore, the binomial table is used instead. So the tabulated value is for the probability in the form of px larger or equal to x, where x is the number of success. So this is what the binomial table look like. So never mind, we will go through how to see the binomial table later. So for example, for n equals to 20 and p equals to 0.5, so px larger equal to 7 will be 0.5834. 0.35 and 7, so it will be here 0.534. For x and for n equals to 20, p equals to 0.5, so p x larger equal to 6 will be 0.9793. Okay, so it's just suitable for you, like you got n trial and 20 trials and you want to find px larger than 10. Px larger than 10, so you need to find like x equals to 10, x equals to 11, till x equals to 20. Or 1 minus p x smaller than 9, but is also is a large number. So instead, for calculate it, so you just use the binomial table. This is what it means. So just okay. So look at the mean and the variance. So if x equals to x b with the parameter n and p, so the mean will be n times p. The variance will be n times p times q. So the standard deviation will be square root n times p times q, which is square root n p q. So I prepare some question. So given x with parameters with 6 trials and 0.2, the probability of success, so find p. X equals to 2. and bx larger or equal to 5, c smaller than 2, the mean and the variance. So px, so I just write out. If you not so familiar with this, you can write out got 6 the probability of success 0.2, the probability of failure 0.8. So px equals to 2, so you can write it as 6 c2 0.2, 2 and 0.8. 6 minus 2, so it will be 4. So you'll get 0.2458. Or you can just, if you want to use the table, the binomial table, you can just write it like this: px larger than 2 minus px larger than 3. So I prepare the binomial table. Yeah. Just now we have how many trials? 6 trial with 0.2. 6 trial with 0.2 here at this column. Oh, I cannot write anything. So I just zoom it. So for 0x larger equal to 2, 0.3446, and 3x larger equal to 3, 0.0989. So 0.3446 minus 0.0989. So I will get 0.2457, which is almost same as this value. So px larger than 5, either you can just x equals to 5 plus x equal to 6 by using the formula 6c5 like this, sum up to get 0.0016, or you can just find it in the table. You can see the 5 column here, 0.0016. Px smaller than 2, so you can just find it does not include this 2. So px equal to 0 plus px equal to 1 by using the formula to get 0.6554, or just 1 minus px larger than larger than 2, because that does not include this 2, right? So so as you can see, 0.3446. So take out the calculator. 1 minus 0.3446. Yeah, so I will get 0.6554. D is the mean. Oh, I forgot the, here's the mean. Mean is n times p. 6 times 0.2, so I get 1 per 2. Variance is n times p times q, so 6 times 0.2 times 0.8, so I get 0.96. Okay, so question 2. A large restaurant offers an average of 3 out of every 5 customers ask for water with their meal. So as you can see, the probability of success will be 3 per 5. So I write it as decimal 0.6. A random sample of 12 customers. So number of 12 will be 12. So find the probability that half of them ask for water with their meal. So I just let x. This x will be the event of number of customers ask for water with their meal. So n equals to 12, p equals to 0.6, and q equals to 1 minus 0.6 equal to 0.4. So I write is a parameter form. So half of them. So 12 divided by 2 will be 6. So 12c6, 0.6 power of 6, or 0.4 power of 6. So I'll get 0.1766, or I use px equal to 6 minus px equal to larger equal to 7. So let me find 0.6. Got or not? If no, I have. Okay, if the p does not have. Okay, so the probability had just still this 0.5. So for this, I need to. Okay, for this, I need to cannot use this binomial table. I just can use the formula. So 12C6, so I will get 0.1766. So B, more than 10 ask for water. More than 10, so does not include 10. So it will be 11 or 12 people ask for water. So just 12C 11, 0.6 power of 11, 0.4 power 1, or 12C 12, 0.6 power of 12 times 0.4 power of 0. So 0.0174 or 0.0022. So I will get 0.0196. Last, less than 3 do not ask for water with their meal. So for this, you can go two ways. You can just let y, you no longer use x, use y with the number of customers does not ask for water. And you just reverse the p and q, so you'll get p equals to 0.4, q equals to 0.6. So less than 3 can just y 3 equals to 12c. So so you need to find y equals to 0, y equals to 0, y equals to 1, y equals to 2. So will be 12c 0, 0.4, 0, 0.6, 12 plus 12c1 plus 12c2, like that. Or second method, if you can, your brain can return, so you can know that less than 3 do not ask will be equal to more than 9 of them ask for water. So I can remain this x larger than 9, so I will get x equal to 10, x equal to 11, and x equal to 12. So just now I have calculate this x equals to 11 plus x equal to 12. So I just sub this 0.0196 inside, and I just calculate this 12C10, so I'll get 0.0834, just like that. So how do you know they're more than 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Less than 3 do not ask for water. This does not ask for water, this does not ask for water. So will be more than 9. So at least it will be 10 of water ask for water. 10 of them ask for water. Because less than 3, right? Just can be 0 or 1 or 2, right? So it will be more than 9. So at least it will be 10 of them ask for water. If your brain can run, can turn, so you can know. If you still feel conscious, you just use my method just now. So no longer use x as the event, use y as the event instead, and you reverse the number of probability of p and q. So p will be 0.4, q equals 0.6. So that's all for the binomial. So next video I will continue with the Poisson distribution.